Welcome student. In today's lecture, we see very interesting electric component called as a capacitor or condenser. What is capacitor? सगळ्यांनी तुम्हाला माहित सुद्धा असेल की कॅपॅसिटर तुम्ही बघितलेला पण असणार आहे, परंतु तुम्हाला माहित नाही की ह्या इलेक्ट्रिक कॉम्पोनंटला काय म्हणणार आहात आपण कॅपॅसिटर म्हणणार आहोत. जसं रेझिस्टर हा इलेक्ट्रिकल डिव्हाइस आहे तसंच कॅपॅसिटर सुद्धा हा इलेक्ट्रिकल डिव्हाइस आहे and each and every electrical circuit consists of a capacitor and a resistor. Then what is the capacitor? Capacitor is an electrical device which store the electric charge or electric energy. Store electric energy. That device is called as a capacitor. Some of the instrument requires the high current. For example, 25 ampere to the 50 ampere to start them. बऱ्याच इन्स्ट्रुमेंट जर ऑन करण्यासाठी एवढ्या करंटची गरज असते. फॉर एक्झाम्पल्स आर फॅन, कॅमेरा फ्लॅश म्हणजे आपण सेकंड वन, थर्ड वन इज मोटार. हे जर इन्स्ट्रुमेंट आपल्याला ऑन करायचे असेल तर वी हॅव नेसेसरी this current 25 ampere to the 50 ampere and this is very large current. Therefore, capacitor is used in this instrument. Example: fan, camera flash, motor, different power supplies, different tuning circuit. यामध्ये capacitor हा काय केलेला असतो, वापर केलेला असतो. It is the basic component which is called as a capacitor, which stores the electrical energy and supply it energy suddenly. हे पण महत्त्वाचं आहे. बॅटरी पण एनर्जी काय करत असतो, स्टोअर करत असतो, but it supplies the energy slowly and capacitor supplies the energy suddenly. कॅमेरा फ्लॅश आपण पाहतो, लगेच काय होतं, आपले डोळे लगेच काय होऊन जातात, बंद होऊन जातात. तिथे एनर्जी काय होते, सडनली रिलीज होते किंवा सप्लाय होते. दिस इज द गुड एक्झाम्पल ऑफ ए कॅपॅसिटर. ओके, देन according to the theories, the work done will be proportional to the Q and therefore V is directly proportional to the Q, or you can say that Q is directly proportional to the V. Therefore, take constant Q is equal to the C into V. Then what is this C? C is equal to the Q upon V. It is important. C is equal to the, we get the Q upon V. Okay, what is C? C is called as a capacitance of capacitor. It is the property of capacitor. जसं रेझिस्टरची प्रॉपर्टी कोणती होती, रेझिस्टन्स होती, तशी कॅपॅसिटरची प्रॉपर्टी कोणती आहे, तर कॅपॅसिटन्स is the property of capacitor which store the electric charge or electric energy. That property is called as a capacitance of capacitor. Okay, if we consider this is the any conductor, okay, plus Q charge is situated on it, fully it is charged. Okay, suppose this is nothing but a charge Q. If we have to add the charge dq on it, therefore if the charge is added on this conductor, then its potential will be the V. Okay, as its potential is V, and again we have to add the dq charge, then what will be there? Then there will be the work done, and that work done is nothing but a dw, which is equal to the V into dq, and therefore we get V is equal to the dw upon dq. Okay, means as the V is minimum, dq will be the maximum, and as the dq is maximum, what about C? C will be the maximum. Okay, therefore indirectly the capacitance of capacitor depends upon the voltage, or you can say the potential. Okay, if the potential should be small, as the potential is small, charge will be the large. As charge is large, capacitance will be the maximum. आणि आपल्याला कॅपॅसिटी ही नेहमी काय पाहिजे असते, ही मॅक्सिमम पाहिजे असते. ओके, therefore this C depends upon V also, and it depends depends upon the size and shape of the conductor and the separation between that conductor also. What is the electrical device capacitor? त्याची arrangement आपण पाहणार आहोत पुढच्या टॉपिक मध्ये. Okay. And what is the SI unit of capacitor? SI unit of capacitor is the farad. F-A-R-A-D. It is denoted by letter F. Small unit are there. There will be the microfarad. There will be the picofarad. Okay. There will be the nanofarad also. 1 microfarad means 10 raised to minus 6 farad. 1 picofarad means 10 raised to minus 12 farad. 1 nanofarad means 10 raised to minus 9 farad. Okay. Therefore, SI unit of capacity or capacitance of a capacitor is the farad. It can be the small unit, microfarad, picofarad, and the nanofarad. We can define the definition of 1 farad also. Okay. From this equation, we get what is the unit of C? Unit of C is farad. 1 farad is equal to the 1 coulomb upon 1 volt. Okay. Then what is the definition of 1 farad? Yes. Can I write? 1 farad is equal to the 1 coulomb upon 1 volt because the unit of capacitance is farad, unit of charge is coulomb, and unit of voltage is the volt. Then what is the 1 farad? The capacity of capacitor is said to be 1 farad if we apply 1 voltage to that capacitor, then see this again. The capacity of conductor is said to be 1 farad if we apply a charge of 1 coulomb to it, then its potential increases to the 1 volt. This is the definition of a 1 farad. Okay. Therefore, what is the capacitor? What is the rearrangement of capacitor? A series. माझ्या हातामध्ये हा capacitor आहे पहा. This is the capacitor. Okay. This is the cylindrical capacitor. There are the 3 types of capacitor: cylindrical capacitor, parallel plate capacitor, and third one is the spherical capacitors. Okay. मग capacitor मध्ये काय असतात तर it consists of the 2 parallel plates. 2 plates असतात. One has a positive charge and another has a negative charge. Okay. And the distance between them is filled up with a dielectric medium. की जे आपण प्रीवियस लेक्चरला डायलेक्ट्रिक पाहिलेलं आहे की डायलेक्ट्रिक म्हणजे काय तो मटेरियल आहे तर इन्सुलेटिंग मटेरियल आहे which only transmit the electrical energy. म्हणजे या 2 प्लेट्स मध्ये आता हा सिलेंड्रिकल कॅपॅसिटर म्हणजे इथे सुद्धा 2 सिलेंडर्स असणार आहे, इनर सिलेंडर अँड आउटर सिलेंडर. इनर सिलेंडरवर पॉझिटिव्ह चार्ज असतो, आउटर सिलेंडरवर निगेटिव्ह चार्ज असतो आणि त्यांच्यामधला जो काही स्पेस आहे तो स्पेस कशाने फिलअप केलेला असतो? इट इज फिलअप विथ ए डायलेक्ट्रिक मीडियम. ओके. नाउ लेट अस सी द प्रिन्सिपल ऑफ कॅपॅसिटर. इट इज अगेन द इम्पॉर्टंट पॉइंट. ओके. Since one point is clear that the capacitor consists of 2 plates. This is the plate P1 and this is the plate P2. Okay. Then since this plate P1 is given to the charge Q, therefore its potential increases to V or its potential becomes V. Then what is the capacity of this plate P1? Then you can say that C1 is equal to the Q upon V. Okay. Now the plate P2 is kept near it. Then by induction, negative charge is displaced on the near side and positive charge is displaced on the outer side of plate P2. And this situation is shown in figure A. What I am saying? Capacitor consists of 2 plates P1 and P2. P1 has a positive charge. It is given to the positive charge. Therefore, its potential becomes V, and therefore the capacity of that plate is the, or capacitance of that plate is the C1 is equal to the Q upon V. Now another plate is kept near it, then by induction the negative charge is displaced on the near side and positive charge is displaced on the outer side of the plate P2. Okay, this is the situation which is shown in figure A. Now figure B, series. Okay, in figure B, plate P1 as it is आहे की त्याच्यावर चार्ज कोणता आहे, पॉझिटिव्ह चार्ज आहे आणि त्याच्यामुळे त्याच्यावर व्होल्टेज किती आहे, V आहे. But the outer side of the plate P2 is earthing. आउटर साइड कशाला दिलेली आपल्याला, अर्थिंगला दिलेली आहे आणि त्याच्यामुळे हा जो काही पॉझिटिव्ह चार्ज होता which flows through the earth, therefore only the negative charge remains on the plate P2. Okay, due to this minus charge the potential at the plate P2 is minus V1. It is not the same, therefore we use the symbol minus V1. Then what is the total potential of the system? Total potential or net potential is equal to the V plus minus V1, and therefore it is V minus V1. This is the net potential of the system. ही ज्या सिस्टम मध्ये आता दोन्ही प्लेट्स आहेत P1 as well as the P2. Okay, therefore what is its capacity? Capacity C2, capacity of the system C2 is equal to the Q upon S. What is V? Here V is net potential, V minus V1. This is the value of C2. This is the value of C1. From these two equations it is clear that C2 is directly proportional to the, C2 is greater than C1 because this factor is small as compared to this, and therefore C2 is greater than C1. Then what is C2? Then what is the C1? Okay, as the C2 is greater than C1, you can say that the capacity of the parallel plate conductor is increased when we get another earth connected conductor near it, and this is the principle of capacitor. येथे लक्षात की कॅपॅसिटी कधी इन्क्रीज झालेली आहे, तर आपल्याला प्लेट P1 च्या शेजारी दुसरी प्लेट ठेवली आणि ती काय परत अर्थिंग आहे की त्याच्यावर फक्त निगेटिव्ह चार्ज आहे. ओके, अर्थिंग केल्यामुळे त्याच्यावर कोणता चार्ज आलेला आहे, निगेटिव्ह चार्ज आलेला आहे आणि त्याच्यामुळे कॅपॅसिटी काय झालेली आहे, इन्क्रीज झालेली आहे. therefore capacity of capacitor is increased when we get the another charge earth conductor near it. Okay, this is the principle of capacitor. Therefore capacitor consists of two parallel plates. Okay, one has the positive charge and another has a negative charge. This is the positive charge and negative charge. This is the symbol of capacitor. Okay, therefore capacitor, an arrangement which consists of two plates. One is the positive charge and another is the earthing conductor अथवा earth plate आहे, conductor plate आहे. Okay, and space between them is filled with a dielectric medium. That electric component is called as a capacitor. Capacitor consists of two plates. One is the charge plate and another is the earth connected plate, and the distance between them is filled with a dielectric medium that is called as a capacitor. And there are the three types of capacitor. First one is the parallel plate capacitor. Parallel plate capacitor. Second one is spherical capacitor, and third one is cylindrical. सिलेंड्रिकल कपॅसिटर. ओके, माझ्या हातात जो काय आहे तो कोणता आहे? सिलेंड्रिकल कपॅसिटर्स आहे. दिस इज द सिलेंड्रिकल कपॅसिटर. दिसतोय तुम्हाला शेप की त्याच्यामध्ये दोन सिलेंडर्स असणार आहेत या पद्धतीने की दिस इज द इनर सिलेंडर. ओके, and this is the outer cylinder. Inner cylinder has a positive charge. Outer cylinder has a negative charge, and its outer side is earth. या हे झालं सिलेंडर. तसंच स्पेरिकल सिलेंडर मध्ये स्पेरिकल दोन प्लेट्स वापरलेले असतील. पॅरलल प्लेट मध्ये काय असणार आहे? दोन प्लेट्स वापरलेले असणार. दिस इज पॉझिटिव्ह प्लेट, दिस इज या पद्धतीने एकावर कोणता चार्ज असणार आहे? इट हॅज पॉझिटिव्ह चार्ज, वन हॅज निगेटिव्ह चार्ज अँड अनदर इज अर्थ. दिस इज ऑल अबाउट द capacitors, types of capacitor, properties of capacitors, which is called as a capacitance, and its unit Faraday. Okay. Here we discuss combination of capacitors. Which are the application of capacitors? See this. First combination, capacitors in series. If number of capacitors are connected one after the another in the form of a chain in such a way that the potential difference across each capacitor is different and the charge on each capacitor is same, then that combination is called as a capacitor in series or series combination. इथे लक्षात की प्रत्येक कॅपॅसिटर हा एकामागे एक जोडलेला आहे. The positive plate of first capacitor is connected to the positive terminal of battery, and the negative plate of last capacitor is earth. That combination is called as a capacitors in series. I have already drawn this circuit diagram. Therefore C1, C2 and C3 are the three capacitors of the capacitors C1, C2 and C3. Therefore charge on each capacitor is, charge on capacitor C1 is plus Q minus Q, charge on C2 is plus Q minus Q, charge on C3 is plus Q and minus Q. Okay, therefore in series combination the charge on the each plate is plus and minus Q, but the potential difference are the different. From figure we can say that V is equal to the, what is the net potential? It is equal to the, V is equal to the V1 plus V2 plus V3. Okay, now what is the value of V1? Just to see, yes, V1 is equal to the Q upon C1. V2 is equal to the Q upon C2. V3 is equal to the Q upon C3. Therefore put these values in equation number 1. Therefore V is equal to the Q upon C1 plus Q upon C2 plus Q upon C3. Okay, if we consider CS, what is the CS? It is the equivalent combination of equivalent capacitors of series combination or resultant capacitance of series combination. Then what is the value of CS? CS is equal to, S you can write down, or V is equal to the S Q upon CS. Then put this substitution here. What do we get? Q upon CS is equal to the Q upon C1 plus Q upon C2 plus Q upon C3. Okay, therefore what is the last equation? Q is here common, therefore this Q get cancelled with the this Q. Left hand side and right hand side से Q का होना है cancel होना है, and we get the last equation which is equal to the 1 upon CS is equal to the 1 upon C1 plus 1 upon C2 plus 1 upon C3. Say this. Therefore we get here 1 upon CS is plus 1 upon C3. This is the equivalent capacitance of the series combination. Okay, and these capacitors in series combination, this is used when we require the minimum value of capacitance. जर एखाद्या सर्किट मध्ये आपल्याला कॅपॅसिटरची व्हॅल्यू मिनिमम पाहिजे असेल तर यू कॅन यूज दिस सिरीज कॉम्बिनेशन of capacitors. Okay, because here is the 1 upon Cs is equal to 1 upon C1 plus 1 upon C2 plus 1 upon C3. Therefore, it is the reciprocal of the equivalent capacitors is equal to the sum of the reciprocal of the individual capacitors. This is the capacitors in series. Now, second combination is capacitors in parallel series. Here the three capacitors are connected in parallel. Okay, parallel combinations म्हणजे काय की it is connected between the two common points. See, the positive plate of each capacitor is connected to here, negative plate of each capacitor is connected to the point B. Okay, and this is positive plate of each capacitor is connected to the external potential battery म्हणूया आपण त्याला. Okay, and negative plate of each capacitor is connected to the negative terminal of the battery. Okay, in this case, in parallel combinations, what about potential difference? Potential difference across the each capacitor is same, but the charge on each capacitors are different. Charge on C1 is Q1 and minus Q1. Charge on C2 is Q2 and minus Q2. Charge on C3 is Q3 and minus Q3. Okay, therefore from figure we can write down Q is equal to the capital Q is the total charge, okay, provided by the battery, which is equal to the Q is equal to the Q1 plus Q2 plus Q3. Okay, then put the value of Q1. What is the Q1? Q1 is equal to the C1 into V. Therefore, it is C1V plus C2V plus C3V. Okay. Then, if we consider Cp is the resultant capacitance of all the capacitors, then we can write down Q is equal to the Cp into V. Okay. Therefore, we get Q is equal to the Cp into V is equal to the C1V plus C2V plus C3V. Okay, now CPV is equal to C1 plus C2 plus C3. This will get cancelled. Therefore, Cp is equal to the C1 plus C2 plus C3. This is the equation of capacitors in parallel. What it represent? The equivalent capacitance Cp is equal to the sum of the individual capacitance of capacitor. Okay? This is 1 upon Cs is equal to 1 upon C1 plus 1 upon C2 plus 1 upon C3. This combination is used if we require the small value of capacitance, and this parallel combination is used if we require the large value of capacitance. This is all about the combination of capacitors, capacitor in series as well as the capacitor in parallel. It is simple point. If we draw the circuit diagram, you can easily write the expression. Okay, let us stop here.